Hi, someone called 903 the best left a post in ElectroBOOM subreddit and asked very good questions, so I had to make a quick video. We know electric current is the amount of electric charge per coulomb passing per second. Now if we get a plastic ruler and rub it against animal fur and charge it and then throw it, can we say electric current is flowing? Does it create magnetic field? But the current flows when there is a voltage difference. Where's the voltage? Is it created when the comb moves? If I vibrate it, does it create electromagnetic fields? What if the charge is stationary and the observer moves? Will there be electric potential created? What do you think? Pause and think about it. The answer to all these questions is yes. Answer number one, yes. If we throw a charged ruler, it is considered electric current. If we put 1 coulomb of charge on the ruler and throw it at a speed of 1 ruler length per second, it will be 1 amp of current. Now answers 3 and 5 are related. Would we have voltage potential if the ruler or the observer move? Yes, if you have watched my last video, you know that voltage is the amount of available potential energy per unit charge, or joule per coulomb. For potential energy to exist, we don't need anything to move. If we have Q amount of charge on the ruler, at any point in space r meters away from the charge, we have an electric field equal to this amount, which has the potential to spend energy on any charge present in this spot, which means that we have electric potential. And if anything moves through the electric field of the ruler, no matter if the ruler or the observer is moving, we create voltage. Look at this experiment. I placed my multimeter here measuring millivolts. The probes are not touching anything, and if I bring my hand close, it's not picking up any voltage. Now if I discharge my ruler and bring it close, it still doesn't pick up much voltage. What if I charge it and then bring it close? Look at that, I'm making a lot of voltage across the probes. Isn't it great? I'm making voltage by manually moving charges. Now if I stop moving the ruler, the voltage drops back to 0 because the meter circuit resistance diffuses the electric energy at the probes. But as soon as I move it, I have voltage. And of course the same thing happens if the ruler is stationary and I move the probes. Now let me show it to you on the scope. I have my scope probe here and my discharged ruler. Now if I charge the ruler and move it around the probe, you see that I'm creating voltage waves. Isn't it awesome? What, you don't share my sense of joy? Answer number 2, yes. Moving charge or electric current creates magnetic field. Let's try it. I'm passing 10 amp through this, ow, hot. Anyways, 10 amps through this wire. Now if I bring my charged ruler close and move it around, it's just attracting. The hell, oh, I know. Well, in a wire, when we run DC or low frequency AC current, the positive and negative electric charges are pretty uniform and equal. So the electric charges cancel each other and all we have is magnetic force. But in my ruler, I have static electricity that even now that I don't have any current running through the wire, it attracts the charges in the wire. The electric force here is much stronger than the magnetic force. If there was only magnetic force here, I would expect the ruler to attract the wire when I moved it one way and repel it when I moved the other way. But now it's just attracting. So although it's creating magnetic field, I can't demonstrate or measure it here. Do you remember Coulomb's law from my previous video showing the force between two charged metal balls? It only works if the balls are stationary. As soon as they move, the magnetic field created between them affects the force. Ah, damn it! The wire melted the shit out of my plastic clamps. And finally, answer number 4. Of course, if I shake it, it makes it. After all, it's filled with charges that create electric fields around it. And I'm shaking the fields, creating electric waves in the universe. And of course, moving charges are electric current, which makes magnetic fields in space too. It's funny though, in a wire at low frequencies, we pretty much only make magnetic fields, because like I said, the opposing charges are equal and pretty uniformly spread. But with this ruler, I'm making electromagnetic fields. Probably more electric than magnetic even. It was a very good question.
903 the best.
Thank you. Now this was a good question and I thought to make it public, but I don't want to spam my channel with the follow-up videos to my ElectroBOOM 101 series. So later, if I want to make quick general follow-up videos to my ElectroBOOM 101 series, like solving problems and answering questions, I'll just make it private and I'll put a link to them in my website electroboom.com, so if you're interested to learn the supplement information, you can go there and watch them.